Okay, so our next speaker is Dr. Sepehr Moghaddam. He is a CMF surgeon and our senior consultant. So you should be joining us. Hello, Dr. Moghaddam. Hello.
Hello, Kelsey. How you doing?
Good, good. You are our last speaker. Certainly not our least.
Right.
We're excited to hear your presentation. I'll go ahead and give you the floor. Our attendees are going to give a thumbs up. You just when they can hear you and everything's running well. Okay.
Awesome. Great. So let's see here. Shall I share my screen now?
Yes, please go ahead and go ahead and share your screen.
Let's see here. Can you share the screen? So there we go. And let's see.
I'm seeing thumbs up from our attendees, so you are good to go.
Perfect. Do you see the presentation only, or do you see the other screens that I have here as well?
We can see the presentation and your pop-up window, so all good.
Awesome. All right, great. Perfect. Good afternoon, everyone. And thank you, Florian, Kelsey, and Jan for inviting me to give this presentation. Let's see if I can get this going on. There we go. I have no financial relationships to disclose. A little bit about me. My name is Sepehr Moghaddam, and I'm an oral and maxillofacial surgeon from Sweden. I graduated from Gothenburg University, where I'm currently also doing my PhD in tissue engineering. And as a surgeon, I'm working in a city called Halmstad, both in the public and private sector. For you who don't know what a maxillofacial surgeon does, I diagnose and treat patients with diseases affecting the mouth, jaws, and face. And as many other medical fields, my occupation have gone through a tremendous amount of development, many through misery of war, and in recent years, thankfully, due to advancement in technology. So to understand where we need to go, we need to understand where we come from. So I have dedicated some of today's presentation to history. The official ground was set during the end of 18th century after the American Civil War, when dentists, technicians, and general surgeons together invented new techniques to treat facial injuries, and the specialty was finally certified by the American Dental Association in 1859. But long before the Civil War, Hippocrates understood the value of fixation and stabilization when treating facial fractures by wiring together teeth with metal cloth. And fixation that, together with repositioning and reduction, has set the standard of current principles of fracture treatment and what we today call reduction and fixation, or most of the time open reduction and fixation. Understanding the pattern and etiology of how injuries occur and how they affect the facial skeleton has always been of interest when deciding the treatment. In the past and even today, with the technology of early 19th century, which basically meant a few cadaveric skulls and different methods of implementing force, René Lefort, the guy you saw in the previous picture, he was able to give us the classification for fractures of the face, which we still use. And when an understanding for facial fractures was developed, standardized treatment could be applied, initially through external rigid fixation and internal wire fixation, or both. But with the modern bone plating technique that started in the 1950s, when a group of 15 surgeons led by Maurice Muller formed AO, also called the Arbeitsgemeinschaft für Osteosynthesefragen, improvements were made to the principles of bone plating. And the advancement, together with the development of alloys, gave us new materials to work with when treating fractures. So for me, this is amazing. Of course, imaging is a major factor for understanding and setting a treatment plan, so that we don't manage injuries blindly. Even here, the technology, as you know, has advanced fast through the years, from plain X-rays like this ones to more advanced ones, such as CTs or CBCT machines and imaging. And with such new techniques and the software, we get sharp images that that we can mentally prepare ourselves for what has to come, create a mental treatment plan, and see details that improve and increases our surgical results. All, of course, depending on the surgeon and the team by being able to mentally transform the image into the haptic that we use when doing the surgery. So thankfully, both for the patient and the surgeons, the technical advancement has no limits and therefore keeps improving, giving us more powerful computers and softwares, amazing 3D rendering, making basically all lives easier, mine and the patients, to be able to plan more accurate and pushing with development further together with the 3D printed models. And as a surgeon, I love 3D models. I mean, I work with my hands, and having that sensation of twisting, tilting, rotating the skull, it has given me a tremendous amount of satisfaction when planning and performing the surgery. It has also made it possible for material developers, like a few of you maybe in this session, to measure, analyze, and create new plating systems and anchorages and screws and all in different dimensions for me as a surgeon to be able to use. So with this amazing technological development of combining imaging, printing, material development, we now have standard plates that fit certain areas depending on the location of the fracture, with mirroring of the images and models that can be created for damaged side based on the healthy side of the face, and therefore also improving again the result and outcome for my patients. I love it. I mean, I love technology and it improves for humanity. So when they go hand in hand, that's the perfect combination. I use 3D modeling, 3D imaging a lot in my field of work. And I use them, for example, for preparing a case like this one, which I did some time ago when the rendering software wasn't as developed as it is right now. And by printing a 3D model, I could see how my surgical field would look like when open. And by doing that, it gave me an accuracy, also making the surgery less invasive for the patient, which means that I could see the model, and then when I opened, I could open a less affected area and do the surgical treatment. And also enabling me to play around outside the operating room without the patient being present and with no stress to find the perfect surgical treatment plan, choosing the perfect plate, bending and adapting it exactly how I want it without compromising. Extremely fun, very time consuming, both when preparing and also when waiting for the product to arrive. Everything from the models to the plates, but absolutely doable. It works, but due to its complex process, it wasn't chosen for everyone. So not all the patients got this kind of treatment, only a few selected ones, mostly on elective cases where the surgery does not need to be done urgently, or at least in a few days, which most of our trauma cases are. And we are always competing with biology, the biology of healing, infections, bone remodeling, age, medication, you name it, a lot. So thankfully, the development has continued, as you can see, putting us where I now have accessible software to use when planning the elective cases, creating a digital twin of my patients so I can, instead of ordering a 3D printed model, use the computer to twist, rotate, tilt, and divide the skeleton. Still very limited though, as every single adjustment of my saw and drill requires a few programmers to plan the next software update. And I totally understand. There is a lot of work behind every system update and software that is created. And I really appreciate you guys putting the effort into it. And I can just imagine how amazing it would be when the time comes that software render a plan like solving a puzzle when the image is uploaded, no matter if the case is a simple jaw fracture or an advanced complex facial fractures due to basically anything. It could be a car accident, a gunshot, violence, and you name it, it generates a plan. And I also do miss the haptics when working like this, but I admit it's just a habit. Eventually, it will be forgotten. So by creating a digital twin, I have both the surgical plan and know exactly what material I should use. I can order a material or use the standard ones that I have. The fact is still that the plan has made it much easier for me as a surgeon and also for the patient with his final result. Not even mentioning the shortening of surgical time, the usage of less material, the exact predictions, and also the training it gives my residents when they can see and play around with the outcome without harming anyone or damaging anything. But still, the question remains: when will we getting to imaging, printing, and planning, bending, and performing in more complex cases, such as this one? I mean, I believe there is a lot of development to come, and inventions to be made, and adjustments to plan. And I think we have just started, because as it is right now, I cannot take a complex case and with computer rendering have a final result moving around all the pieces and all the aspects. It's working with the softwares that I've used with more singular parts, but having specifically for every kind of patient is still not there. At least I haven't experienced it yet. So there are still, there are a few pros and cons with the present methods. And as mentioned, the cons are accessibility. It's very time consuming as it is right now. It costs a lot. Not every hospital can afford it. Not every patient can afford them. It requires a lot of knowledge to be able to use the system, to know what to order, what to think, what to want. And it, of course, it's non-multifactorial. I'll soon get back to that. And the pros are, of course, the technique being functional, it's accurate, it's biocompatible, it's aesthetic, it is safe. It's a great way to work, and well, love it. So as I mentioned before, we are all not made similar. We might look similar when just looking at the skeleton, but we have many differences. Besides gender, age, and race, previous medication, in muscular contour, skeletal strength and contour, and we need new methods that are more specific. They don't need to be different in all aspects, but there should be some parts that are standardized and some parts that are customized. And who knows, maybe we'll print some parts when treating fractures in the future using advanced and modified plates together with bioprinted parts and material. I mean, me being one of many looking at new methods as part of my PhD, here, as you can see on this video, I'm printing some grids with a 3D bioprinter, and these grids contain stem cells that I have done in vitro studies on and see if these stem cells then can transform into bone cells. And so far, it's amazing results, and it's amazing to see how it works. But we've got a lot to go, and it shouldn't be rushed. So, which brings us to the area of improvements, and I hope that many of us work towards to develop these. There are a few of them. I mean, some of them that I've written down for you here are, of course, accessibility, the time-consuming, cost efficiency, but also they need to be adaptable. They need to take into consideration the bone, the background material, soft tissue, age and gender, as I mentioned earlier. So we are going on a very nice direction, and as a professional in this field, I love to see the development, and I hope that one day I'll be able to see and hopefully even experience the ultimate custom made. So we'll see where we are going. And yeah, thank you for listening. I think these were my 10 minutes of presentation. So I've got 5 minutes for talking. And thank you for listening. And Florian, Kelsey, and Jan, again, thank you for inviting me as a speaker today.
Thank you. Okay, we're getting some applause emojis here.
Yes, lovely cyber world. Thank you all.
Okay, so I have a couple of questions from my end here. Let's see if we can change the screen here. Sorry about that, having some technical. All righty. Okay, so a couple of questions on my end here. I have, so how can we as developers, we've had some great presentations. There's definitely energy there, investment, and a great opportunity, but how can we as the companies developing these tools accelerate getting this technology into clinicians' offices?
I mean, to get the advancement that we want, the technicians and the companies need to have a very intense and very tight collaboration with the practitioners, the surgeons in the field, because there are a lot of things that the technician think about when it comes to engineering a product, but when applying it into a surgical field is not the same. For instance, I can take an example. When I initially ordered guides for my surgical preparations and drill holes, etc., they were made in an engineering way with cylinders where I could put my drill in, etc. But those cylinders were accurate 90 degrees towards the angle of the bone, etc. But for me to get access to that, I cannot rip off the whole face, not most of the time, but I mean, and have that angulation. So it had to be adapted and adjusted. So me having the communication with the technical area made some improvements, and I could order the things that could fit my surgical area. So I think the collaboration is very necessary, and it requires a collaboration among the whole aspect of for instance, if I take just my specialty as an example, there are young surgeons, there are old surgeons, there are advanced surgeons, etc., etc., and everyone is doing they have the same goal, but they're doing it in different ways. There is a lot to understand, and there is a lot of information to access when having these collaborations, because it helps us to think and apply the new engineering techniques faster, modifying it faster, improving it faster, instead of first producing something and then releasing it and then have to update and adjust, etc., etc. Because as you know, Kelsey, there are a lot of companies that work towards the same goal. So for being successful, it requires an amazing networking. So that's where I see it and how I see it, as a little long answer to your question.
Yes, I thank you very much for that answer. I can see how the liaison here is kind of what we're trying to do in this presentation. We're bringing you as a senior consultant and a surgeon in touch with the people who are developing the software, and they may have the best intentions, but until you get there and, like you say, take the face off, you're not going to know. And that's why we need surgeons in the field. Yes, absolutely. And the people in the offices using the technology and etc. So I have one more question, then we can go ahead and start networking. What hurdles do you think we face getting this technology through, piggyback on your answer, through the hospital administration? So more of the surgeons might be on board and the tech companies are working with surgeons, but then we need to get that approved to be implemented. And what would you suggest? How can we kind of?
Of course. I mean, a lot of this technologies are improvement of present technologies, which means that they are not completely new technologies. The areas where, for instance, I'm doing my PhD, it requires ethical applications, proving, etc. But that is way too far. It takes time. But as it is right now, to get that collaboration, I think, and I hope, because of the technical development that the new generation of surgeons have gone through the past 10, 20 years, they are more accessible to trying and adapting to new techniques. And as I said, because the technology is not completely new, it's just modification, the process of applying it is probably much easier. Of course, the hospital administration, when it comes to money, everybody wants to gain from it, and it doesn't need to cost, etc., etc. But the selling pitch of developing such techniques are tremendous, because it's not only the benefit of the patient, it's also saving money on material, unnecessary usage of material. It's education for the residents, being able to work on something without harming anyone. So there is a lot to gain, but of course I know it's hard with administration and bureaucracy. So it requires a nice team that understands it to be able to sell it and apply it for the hospital area.
Keep fighting the good fight, so to speak.
Exactly.
Okay, wonderful. Thank you so much, Dr. Sepehr.
Thank you.